Hello everyone, my name is Kamalika Majumder. I am an independent DevOps consultant and also a infrastructure security practitioner. I am also the founder and director of Stacks LLP, that is my company name, and 10 Factor Infra is the website, so you can check out more there. Today's topic is about test driven delivery of infrastructure as code, and I am going to cover 3 major blocks here. First, we are going to see why test driven delivery of infrastructure and why I call it delivery and not just development, because we all know TDD as test driven development, but I as an infrastructure consultant, infrastructure developer, I call it test driven delivery, and I am going to explain why. Then we are going to see how to build your infrastructure so that it is test ready, the code, and then we are going to see a quick demo on writing tests and how to execute tests on infrastructure as code. So, why test driven delivery of infrastructure? For me, based on the experience I have seen for more than a decade now, test driven testing is important for anything, be it application or infrastructure. I think security and compliance, especially today, is the topmost reason why we should do testing. And the reason, because I prefer calling security and compliance at the topmost reason is because the kind of importance it has today. PCI DSS, one of the most common compliances, the last version 3.2.1 expired last year, and they released a new version which is version 4, and it had around like 50 new rules related to infrastructure and configuration and security. Similarly, ISO 27001 2013, which is one of the you can call it the global compliance for information security or IT security. This also is going to expire on this year on 31st of October, and all the organizations have to upgrade to the new version, and this has obviously gone through a lot of change. So, you can see like the last version was released in 2013, and they released the latest version which everybody has to upgrade this year is 2022. Now, as technology evolves, and we are seeing it more in past 3 years with the advent of AI and LLM and things, we will see more improvements in security compliances, if not addition, if not more compliances, but at least on the existing compliances itself it will evolve. So, organization cannot always depend on last minute evidence collection, last minute certification. It's not possible, it's technically and physically not possible to achieve that, and because of that test driven delivery becomes all the more important, because these changes will keep happening more rigorously in the coming future. The new ISO 27000 2022 version, which is the latest version, which it had already, people have started upgrading to it. It has 6 specific controls just directly linking to testing and testing of infrastructure. It has controls such as information backups should be tested, and it should be maintained, recorded, and everything should be documented in that way. It says the security must be maintained in development, test, and production environment, and those environments should be maintained in segregated in such a way that the security of the data stored in these like say production environment does not get compromised with the data in the test environment, and likewise. Again, protection of information systems during audits is very important, and that is a specific control in ISO 27001. Likewise, the IT readiness for business continuity. Organizations should test their applications, systems regularly so that they know that their organization has the business continuity requirement that it needs. Likewise, in PCI DSS, the latest version, there are at least 14 such controls or requirements which directly links to testing your systems, your network, and infrastructure. So, the reason I picked these 2 compliances is because these are the most common compliances that at least the software development organizations, technology firms need to comply to if they want to build that trust with their clients, customers, whatever you may like to call. There are also other compliances with more stringent measures, but these are like you can say the first level of compliance that almost any global IT company needs to comply to. Also imagine these scenarios, onboarding million users in a day. We have so much development happening today, we have moved beyond just mobile application development. We are moving towards AI application development, and those all of them are targeting consumers or customers. How many can you onboard, how many can you serve, how many data can you process. So I am just giving million users because that was one real scenario that I had worked with for a digital banking platform, and this was the first release that we had done, and the requirement given by the business was that we need an app which is performant enough to onboard a million user in a day. To be honest, it was in a couple of hours, like the situation was they would hold an event and there will be booth and kiosk. They will do marketing, and people will come there, and right there they will create their accounts, they will do some mini transactions, and likewise they will showcase that they are ready. And this was a bank in Indonesia, and this was a bank which was fully on cloud, no branches and nothing. This is a completely digital application. So likewise there were other scenarios that you see in these kind of enterprises, like building audit ready production environment. Every year you have to go through audits if you are in financial services, or in some cases even in the technology firm. Financial services, it's a must. Every year you must go through an audit. It may be one audit, it may be two audit, multiple compliances, single compliances, depend on the country where you are in. If you are in India, I think in India there are two, if you are in Southeast Asia, maybe in Indonesia there are one specific to the country. So there may be multiple compliances that you have to do it, and you most of the time engineering teams come to know these requirements just a day before or a week before, that we are going to have an audit on Friday, please be ready. That's it, right? Now what does that mean? Please be ready. And then when being asked what does that mean, they're like, yeah, if that audit fails, then our application or product will no longer be certified. That means it may lose its license, and in some cases like the fintech solution or the financial services, the banking apps, it's a big thing, because if they lose their license to operate or they are not certified, then that means the business is almost done deal, right? So engineering teams had to get ready to build environments, to provide those kind of infrastructure, so that there is a mock-up, everything is ready there, there is no loopholes, because it's just one day. The auditor will walk in, it will ask questions, and they will review everything. Everything should be there. If you fail it, it's gone, right? And similarly, there are events such as disaster recovery drills where you have to comply to. Nowadays, you see various platforms. Not nowadays. Ever since the service level, the software as a service as a concept was launched, the concept of SLA had always been there, right? 99.95%, 99.99%. Like, how do you find out they are actually complying to it? So just disaster recovery drill is one of the, testing is one of the activities that does. Migrating customer data across cloud platforms. We are moving so fast in our technology landscape that it's not just concentrated to one cloud. Today you are in one cloud, today you might be in AWS, but tomorrow GCP might release something very cool for some of your analytics that you want to move to GCP. So how do you migrate those kind of data? And data is moving rigorously today. It's no longer, I think TBs is no longer the case that TB of data or 3 TB. I think it's much beyond that. Hundreds of TBs, hundreds of GBs. I'm talking about this like maybe 1 or 2 years back. That was the situation, and that was the first time launch we were doing it. So data is growing. If you want to move it, migrate it, export it, that also needs testing. And all these had to go through maybe a live digital banking infrastructure with zero disruption. You can't stop your business. You can't go and say 3 years back, 4 years back, maybe there was a maintenance window concept in banking sector. Maybe in weekend we could say, okay, night time this to this, we should have a scheduled banking system. We know today Indian banks like State Bank of India and others, they still have that. How much as a consumer we get frustrated when you see such a banner, right? NEPS will not be available, you know. We as a customer get frustrated, but when you think as an engineer, we will understand, you know, they need that bare minimum window, but that is also not acceptable today. You do not get those kind of maintenance windows. So, you have to perform all these testing, everything while your application or your system is live. So, how do you do it? So, all of these, that is why I like to call, that is why test driven delivery and not just development, especially when it comes to infrastructure. It's not enough to just have a script to deploy a cloud environment. Unless and until it's working, it's delivered, even if it is to a developer or a tester or a, you know, maybe a performance kind of event, that is always related to delivery. So, it's beyond development, it's delivery. Reason, reduce burden on application development cycle. We can't always depend on application to tell us that infrastructure is working, because if we do that, when the application fails, and maybe the reason is because the infrastructure is not you know, architected or set up properly, we will not know. We may blame the infrastructure, we may blame the application, because we will not know if the integration points are working fine. So, we have to reduce that burden. We have to know before the application is deployed, if, you know, that the infrastructure is ready for this kind of application. So, when you have your application architecture finalized, I recommend providing it right away to your infrastructure designers or developers, or start building your infrastructure with respect to your application architecture, not you know, after it. Don't wait until you have a nice MVP ready and then you go ahead and say, okay, I need a production environment. Don't do that. Start from logical design and, you know, start testing it. So, you will reduce a lot of overhead that comes in the application development later on, because application itself has a lot of work to do in terms of functionalities, features, etc. Maintain production sanity, it must work dev to prod. I mean, it's been what, I think the word DevOps was coined what, in 2009, and this is 2025. Oh, then we are only changing the, you know, it does not work on my computer, my server, my laptop, and now container, it does not work on my container. I see those memes coming up, right? It does not work on my pod. Maybe we will hear next time, it does not work on my agent. Who knows? It never works, right? It works, you know, in my pod, it never works on the production. Why is that? Because we are not doing enough at the you know, baseline level, at the development level or at the testing level. So, we need to have an infrastructure which works, which is production like right from the development from the beginning. Zero downtime updates, because of that, as I said, right, maintenance windows, taking a site down, especially a site which is serving customers, is really difficult nowadays. Customers will leave you and go to your competitor if you have like 4 hours downtime. You know, yesterday 1 hour UPI was down. You know, I didn't even know UPI was down. Half of my, you know, housing complex people are frustrated because they were not able to pay for all these, they didn't have cash and things like that. So for 1 hour people were all frustrated and nobody had cash. Later on at night I came to know UPI had some technical glitches for 1 hour and it was already in news. So think about those kind of things. You cannot mock cloud on your laptop. Let's just be very clear. Kubernetes is not cloud, okay? Minikube is not cloud. Cloud is much beyond that. There are a lot many layers which goes in before it comes to platform. And even the clouds are not same. AWS is not same as GCP. GCP is not same as Azure. There are very you know, fundamental level networking differences between these clouds. You will only come to know when you are actually migrating from AWS to GCP. You know, I have had instances where people are stuck at migration from AWS to GCP for like 1 year or 2 years. You would wonder why. You are already on one cloud, you can just port, right? That is how the cloud providers or the tools or the platform promise you that we are cloud agnostic, we are portable. But that is not the case, because fundamentally the network layout itself is different. The way AWS, logically it might seem all, you know, nice when it is abstracted and virtualized and shown to you, but underlying it is very different. The way AWS designs its network data centers is different than what AWS calls as availability zone is not exactly same as what GCP calls its availability zones. They have something as zonal and regional and things like that, and those are not just terms, those are actual, they have a meaning, and that's directly related to say disaster recovery. AWS's availability zones are actually availability zones which are data center, who are distanced from each other. But in GCP you might find availability zones which are actually 2 floors in the same building, and it's a real scenario. And whenever you launch a cloud in a new region, that's usually the case, because a cloud provider cannot do everything on day one. They move and they scale gradually. So that's why you cannot mock on your laptop, you have to apply it on the environment. So you have to start from the development environment itself, while designing the infrastructure. You should not and cannot run tests in prod. I think it's a known thing for us. No test should be run on production. You can have a prod-like environment when you want to run, because in some cases you do need a replica of production, like say audit testing and maybe disaster recovery drill. That time you can mimic it. So if you have test driven delivery, and I'll show you how you can do it, how you can structure your code so that it can be replicated easily. That's why I called it test driven delivery and not just development when it comes to infrastructure, because when you are designing an infrastructure and let's say a startup has just started building some kind of product and they need an environment. Now some people may think it's just a development environment, right? But imagine if that development environment takes like 2 weeks to build, or 2 weeks to take, or maybe even after development, let's say you are closer to your production release and you have to do performance test, and you have built a mobile application with say 5 different services. So you have 5 different teams building your services, pretty much they have the same application layout, so their infrastructure requirements will be same, but then each of these teams have to wait for like a week to get an environment. Now imagine how your release date is going to be impacted. What if you start considering infrastructure development is as delivery, like I am giving this environment to a developer to write his code or test his code, but it is a delivery in my perspective, because I am giving, developer is my customer in that case, my internal customer. A developer's customer will be the client, So we need to have that mindset within the organization itself, and then only we can speed it up, otherwise it keeps getting delayed. So that's why I specifically like to use the term test driven delivery. Now test ready infrastructure as code. Before you start writing tests for your infrastructure as code, it is important, like in software development, there needs to be certain structure to your code, certain best practices, certain modularity that needs to be brought into your code. Otherwise those tests cannot be effectively executed, or I may say that the results that you are expecting, the faster results, the better results, you may not be able to get. So how to build test ready infrastructure as code? First up, you need environments on demand. If you are really willing to scale your product or software, you really need to have a mechanism where an environment can be brought up, configured, and then if required also decommissioned once the work is done. You need to treat environments as commodity items. They cannot be static, at least during the development or the non-production cycle, right? Some of it you can keep, but you need to have the capability where the environments can be launched and can be decommissioned at your will, at your demand. What does this enable? This will enable you to truly utilize the benefits of testing or test driven delivery, especially where is testing mostly required. Infrastructure testing is very important in cases of performance based autoscaling. When you are doing your performance testing, you need the infrastructure which can mimic that kind of load, resources, CPU, is your application capable of signing up 100 users in 10 minutes or like 15 minutes. It's not just the application, it should be the infrastructure as well, which should have those concurrent incoming input output resources which are given in there. So, in those cases you need those performance testing environments to be launched, and once it is done you have the results, and once you have the results you have to give it back to the infrastructure development so that they can reconfigure or scale it up or scale it down based on the performance test before it goes to production. And that is why these environment on demands are very important. Another thing is, if you have environments on demand, you will also be managing your costs of infrastructure. If you have like one static environment, what happens is it starts growing it starts scaling up instead of scaling out. That means you keep adding CPU and RAM onto your servers instead of just adding more smaller servers for your applications to consume. So, in those cases what happens is that at some point of time you will forget that, oh, this was some kind of test environment. Most of the time organizations, enterprises today who come back after a year and say, oh shoot, how is my infrastructure cost crossing like $50,000 a month. They come back and they actually say, oh, someday I created an S3 bucket which is no longer, nobody is using those buckets or servers or whatever infrastructure, but it's still lying over there. And there are also risks of taking POCs to production. I have also seen good enterprises, banks taking POC environment which was built for testing some kind of platform, they had just simply taken it to production. So, there are those things. So, I think when you build environment on demand, your infrastructure becomes immutable, means it cannot mutate. We know mutation is bad, right? We have seen it from 2020 to 2021 with COVID. The more anything mutates, be it virus or your server, it's bad. It's bad for your credit card, it's bad for your company, it's bad for your application also. So, it should be immutable and it should be backward compatible, and so that you can play around based on your requirement, you can do your testing. And the third and most important, as I mentioned earlier, even the compliances today specify that there should be a separation of development, test and production environment. There should be separate environment, the testing data should be separate from what you are using in production. Do not use production data for testing, you should sanitize it and then use it for testing, because you will run into issues such as leaking. We see that leaking of customer credentials because it was left onto some test environments which did not have the protection and things like that. So, even the compliances who traditionally we consider as bureaucratic or like say boring, non-technical, they are also talking about technical configuration stuff. So, this is one of the important thing that you need to have your infrastructure as code such a way that it can create environments on demand. And how do you do that? You should have modular infrastructure as code. Do not put everything inside one Git repository and be done with it. That's the worst shortcut that you can take for your infrastructure. Even if it's an EC2 server and an S3 bucket and maybe a cloud front endpoint, maybe it's as minimum as that. But even then, do not put everything inside one Git repository and then leave it there, because it will soon grow into a monolith which will be like a beast to capture. So, what you need to do is don't just automate, modularize and parameterize. Make sure the configurations are all parameterized and the infrastructure resources are divided into modules. I will show you how you can do it. So, basically today you may have one team who is working on one feature, but as your product grows you can have another team which may be using the same resources, but building a different feature. So, how do you give this whatever work you have done maybe for a month to build your infrastructure for your first team, how do you reuse that for your second team? You can't then the next team comes in, you can't just go and say, oh, I need another 1 month to build my environment code, infrastructure as code for my second team. right? The business will ask you, what did you do for the first, why can't we reuse what we built? Just like in application, right? We try to see what are the repeatable libraries and we try to reuse them as much as possible in our application. So, that is why you have to structure your infrastructure as code that way. Segregate your code into reusable modules, the kind of based on what infrastructure resources you are using. So, I like to call these as modules directly linked to the resources, such as if you are on cloud, maybe EC2 is a resource, S3 is a resource, the services that you are using, individual services, create separate modules for them, put them in separate repositories, just like you do for libraries, just like we use, you see what the open source community does. They have individual repositories for libraries, because then the modularity increases, you can do development, you can continue it in parallel. You do not have to depend on one single repository, and if something breaks or somebody is testing something, you need not wait for it. So, divide your resources into modules and then create another set of modules which are called provisioners, which will be your environment deployers. So, these terms are very common when you are building infrastructure as code, especially if you are using Terraform like tools. There are other competitors of Terraform now, like there are Pulumi, or there is a Open Tofu, which is kind of like a fork on Terraform, like an open source thing, but it's pretty much the concept is same. They also work on modules. So, you can design your modules in such a way that there are some base modules and then there are some provisioner modules which will actually do the deployment. And if you have it in that structure, then you can have your test placed in different level. So, you can have your linting or formatting tests, which will check whether your syntax and things are working fine or not, and this can be your pipelines, the CI/CD pipeline, be it Jenkins or GitHub or GitLab, Bitbucket, whichever you are using. And you can have a validate and plan. So, you can do it in stages, just like you do in your application development. You have unit tests, you have functional tests, you have integration tests, you have performance in different stages, different jobs, you can structure it. So, likewise for infrastructure also, if you divide it into modules and provisioner, you can do individual level, repo level, lint test, validation test, then module level test, then finally you can have the provisional level test, which will kind of be test your application architecture, whether it is working end to end or whether you can you might test the endpoint of a cluster or maybe a API gateway and things like that. This is a GitLab structure, but you can mimic the same thing in GitHub or in Jenkins, whichever is your CI/CD platform. So, I like to place it in this way, like you can say with every merge request being confirmed, it will run a default linting test, which will check the format of your code, so that it checks for your syntax errors and things like that. And then I have individual set of stages for network, system, storage things. Network, it actually creates the VPCs. So, I do the validate first, then plan, and then apply. So, likewise you can have that. So, here what you do not see are the module test. So, basically here you can apply module test, and then at the end, before the destroy thing, you can add like an end to end test. Maybe you are building a mobile application. So, one thing to test for your mobile application is your API gateway endpoint working or not. So, you have deployed the API gateway. So, what you can do is you can deploy a dummy service on, maybe you are using Kubernetes EKS. So, then you can call the API gateway from internet. So, you can write a test, we can do a quick curl on that. So, that gives a basic idea of the connection between API gateway to EKS cluster to your MongoDB database is working fine. There is no unknown port blocks or things like that is happening. Next, so now starts the demo. So, I am going to use Terraform code, and I am going to use two testing tools for infrastructure. One is Inspec. Inspec is by Chef. I do not know how many of you remember, there was a company called Chef, much before I think even AWS came into picture. So, they have also quite a few of these testing tools. So, one of them is Inspec, and I am using TerraTest. TerraTest is by Gruntwork. TerraTest is based on Golang, so it uses pretty much the same structure as Golang uses. It has actually some libraries which can call terraform functions and things like that. So if you are familiar with the Golang code, it will be easy to it. Inspec is not, Inspec is actually a DSL like Terraform. So you don't need to really be a programmer. So it has declarative structures and resources which it uses to test. TerraTest is more, is basically a Golang code. So it's a Go file and you run it. So if it's pretty simple, but if you are not familiar with Golang, it will be better to just get familiarity with Golang. So the first thing is how to structure your code, and I mentioned that segregate your code into different modules and provisioner. This is everything here is Terraform modules, but I am structuring it in a different way. So I have my modules are equivalent to the resources that I use. So as you can see, I have every AWS service that I am using for my application here. Like I have the AWS Certificate Manager, Audit Manager, EKS, network. So if I go to network, so network is basically, it will create a VPC, it will create 3 different subnets, public, private, protected, and then it will create the gateways and likewise. So this is a structure that I was talking about when I said modular infrastructure is good. So if you let's say you have decided that AWS is the cloud that I want to launch, or GCP is the cloud, and you have identified, okay, I want to build this application, I need a MongoDB, or I need a Postgres, I need an Kubernetes cluster. So in AWS it is EKS or ECS. EKS is mostly preferred, and I need some S3 buckets to keep my assets, images, etc. I will be needing load balancers or API gateway if you are building APIs. So you would already identify what you need on AWS. So suggestion is when you are actually building from day one, divide it into individual modules, modularize each and every part of it, so that any more teams that come in future, you can actually build your environment just by calling these modules, and you have a base standard applied to, like in case of my network, I want any VPC that is being launched for my organization, it has to have segregated network. It has to have a public, a private and a protected network. It has to block all incoming traffic and only whitelisted traffic. So that's the standard that I want to set. So I will build my network module, a base module where I will configure all of these. And tomorrow, it doesn't matter if 10 different teams or 10 different products are launched in my organization. Everybody will be calling this network module to create their VPC. So I know for sure that in my organization, every network that is getting created is aligned with the standard that I have set here. Nobody is going to create a separate VPC module and bypass it saying, oh, I will only use one network subnet and put everything inside it, right? Because that's not the security or the compliance requirement is. So likewise, for each of these modules, that kind of capability you can build and you can reuse it as many times as possible. And once you have that, you have the provisioners. So provisioners, as I mentioned, these are also Terraform modules only, right? Only the purpose of execution is different. So provisioners, as you can see, I have an admin environment and I have a ISO related environment, I have a management, non-prod, prod. So if you look at my non-prod environment and the base module, so I'm calling a So I'm calling another module here which creates a Terraform backend and creates a Route 53 domain. Right? The first thing I do is I create a DNS domain because that's what I will be needing for running my EKS services for certificates and things like that. I need a DNS for that, right? So maybe I'm using 10factorinfra.com, that's my DNS name. So let's say I need that, so first that's the first thing that I am using it. Now when you do it, it's calling two modules in this provisioner, which are here likewise, right, and similarly like root 53 here. So now I can test individual provisioner here, and this is the first example using inspect. So in inspect, so this is the standard structure. When you actually install inspect, it will, and you do inspect in it, it will create this structure and it will follow that. So you don't have to manually create this structure, it's pretty much the same thing. So in this under verify controls, you need to create an RB file. Inspect is based on Erlang is Ruby. So that's why you see RB file over here, because Chef is actually based on Erlang and Ruby. So this is an inspect file to test my base module. So my base module, in my base module I am creating a terraform backend, and in the terraform backend I am creating an S3 bucket, a KMS key and a DynamoDB. This is required for terraform backend in case you want to store the, not in case, actually it is a good practice to store the terraform state files in an S3 bucket and apply a lock to it, so that you can do simultaneous development. So I am creating three things here: DynamoDB table, S3 bucket and the file. And here is how my test looks like. I am testing it unit by unit, right, because first I will execute the base module, base provisioner, and once I do execute this, I want to check whether it has created those resources in the same way or not. So you can see it is, I have given these variables where it is a public zone ID, name server, this. So now what inspect does is, it will look at the output of Terraform and then it will query the AWS APIs, and it will kind of correlate. If you are creating, let us say a public zone, say with 10factorinfra.com, it will actually go and take that value and the ID and go to AWS, query it, match it. And sometimes it maybe the DNS zone was not created on AWS properly, it is in some kind of, let us say, verification failure and things like that, terminating state. Sometimes it might happen that the cloud providers endpoints are not working properly, or something in your code may be wrong. So that is why I have the logic that the name server, it should have at least 4 name servers, that is the standard. The private zone, it should be a public zone, and it should have all the name server names, so that it can check it. So now what is this visible? Okay. So let us see how to execute this. So for the sake of this demo, I have already executed it. So if I run it now, it will actually show the output that there is already there. Now one thing in inspect is that you need to give it that output file. It cannot run Terraform apply or Terraform init, it cannot execute Terraform. So it basically checks after Terraform is executed. That's the fundamental difference between inspect and TerraTest. TerraTest, since it's Golang based, you can also execute Terraform and then you can add as many logics or curl and all those kind of things to check it that your integration is working fine or not. So that's the fundamental difference. So now you see that it already has this output, and the output in Terraform is stored in a file called tf state. In my case, I am using an S3 bucket to store that file, the same S3 bucket that I created in here, right. Now I will run, first I will need to query the output. Yeah. So this is a command that you need to run. So what you need to do is you need to take the terraform output and put it in a JSON file, because inspect can only read JSON files. So terraform output is a command which actually shows your output in your terminal window. It's also stored in the file, but it can do that. So this. And then you run the inspect command, which will go to the test verify folder, and it will run AWS. So this is the inspects resource or library for AWS. Likewise, it has a similar resource for GCP and Azure and things like that. You can go to chefinspect.io, you will find the list. And when you execute this, yeah, I don't know how much of it is visible. Is it visible? Okay. So you can see, right, here it has everything is tick. Now if it fails at some point, it will give like a red color cross and it will say no, this condition has failed. The reason I like inspect is because it gives this kind of report, because when you are using it in your CI/CD tool platform, you can actually generate this kind of report. You can put it in a file, output file, and then you can kind of export it to as your reporting term, from like you do for your SonarQube test reports and test coverage and things like that. So this is what inspect does. So these are some of the outputs. I don't know, this is from the network. I can do the same thing here. So now likewise, if you see my network module also, I am creating a VPC which has 3 subnets and which has 2 availability zones, and my availability zone is Mumbai, and these are my subnets 10.11, 10. On this, right. And if I have to run inspect in it, I will first do the terraform output here. Yeah. So this actually checks the VPC subnet with the subnet ID is there or not. Are these states pending, or is there any subnet that is in a pending state? Sometimes what happens is due to some stale security groups or some kind of routing error, subnets can remain in pending even if you have everything executed and things like that. The status of the subnets might remain pending, and sometimes even for Terraform, even after it finishes a successful execution, things in AWS may still be waiting to become active. So in those cases, tests like inspect is very important, because then you will know whether it has become active or it is still in a pending state or in a stale state. Now let's look at the Terra test. So Terra test, as I said, it's a Golang based tool, and you can in Terra test you can actually do everything that I have these activities like Terraform apply, then Terraform output and all those things. Terra test already has functions for that. So as you can see, I have built an EKS cluster. So in the EKS cluster you can actually, you don't have to execute the Terraform apply command before this running this file. You can just create this file, like I have an EKS cluster which has a load balancer and an ingress created with a public endpoint, and the public endpoint is the DNS is shared ingress backend. That is the endpoint thing. So when I execute this and I have this function which will go to a browser or maybe curl to test whether this EKS endpoint is working fine or not. And the output looks like this. I am not able to run it now because I have decommissioned. Sorry. Okay. Yeah, yeah. So when you run, I don't know if you are able to see this. So it's basically a go command where you say go test -d. This is a standard go command to run any go file. So this terratest file is a go file. If you see here, it's actually e2e test.go. So you create this and then you go to this the folder where this file is and just run go test -v. Or if you want to run specific functions, so you can say go test, then this function name, test EKS ingress, test, you know, individually you can also run. If you like don't want to do everything in one stage and in your CI/CD pipeline you want to do it like, you know, you want to have more visibility to the stages, you can do that. And so basically as you see, it is initializing backend and then initializing module, everything it is doing, you know, what inspect needs to do before inspect gets executed. Terratest actually has everything. So it will run all these and things, and here's what the final output looks like. So it will actually show a pass, test EKS cluster, test EKS ingress and test load balancer. It will, so you see here it is actually running an HTTP GET URL EKS ingress dot my domain name, and it is actually doing a curl to it and it is able to successfully reach that. That's why it has failed. So that means my EKS cluster and my ingress is working fine, because in Kubernetes cluster it is very important that cluster and the ingresses are working fine. If the ingresses are not working fine, then the deployment, when you deploy your application, it may not work because it will only be a local deployment in the Kubernetes cluster. You cannot access it from outside. Now because I am building a Kubernetes cluster so that I can point it to my API gateway, it can work that way. These are the links, docs.chef.io/inspect. You can look for terratest.grunt.io, and yeah. So finally I would like to close saying some of the major incidents that happened in last 2 years since 2023. Major corporation which at one point one of these incidents in fact took an entire country's airport services down. We know which one is that. That was a CrowdStrike in July 2024. I don't know if you guys are aware that United States, UK, most of Europe except India, everybody were getting blue screen error in their airports, and the reason was very it was because of a known bug which went on to that Windows, and in fact a couple of months before that they had the same issues with the Red Hat platforms. Since Red Hat was not used for these global industries, they did not know it. And likewise, recently in March 2025, in this month, actually CloudSeek had discovered a breach in Oracle Cloud OAM, the Access Manager, and the estimation is around 6 million data records have been compromised. Oracle has denied it, but CloudSeek has proved that it is actually affected, and that's also same, unpatched systems, known vulnerability in Oracle, and it has been known since 2022. So these are not like 0-day vulnerabilities, something they did not know. This is something known and has been there in the system, but they still fail to manage it. And in 2023, the data report by Thales actually identified that 55% of the time that organizations who were impacted by these security incidents, 55% of the time that was because of human error and misconfigurations in their infrastructure or some kind of setups. So that's why I say that infrastructure testing is not just a good to have feature, because every time I talk to software developers or engineers, last year I gave the same talk to AWS community groups, and they like it. They like infrastructure testing, they like learning tools. But when I ask them, would you be implementing it? Yeah, I'll try. I'll talk to my manager. I'll talk to my team. I haven't heard back from them saying, oh, I have tried it and this is how it works. So I think it's a mandatory requirement. I think these compliances are forcing it, which is a good thing, and more compliances should force it. Maybe then the organizations will realize that how testing is important, because Yeah, there is one thing about governments, right? You know, they can make things done. So that's about it. This one, this one. On the TerraTest website, they also list down another 5-6 tools for infrastructure testing. I would suggest try them out all. I didn't have enough time to actually showcase all of them. I just picked up 2 which are quite, you know, use cases I can showcase. So you can try out all those. And you can visit my website, or you can connect me on LinkedIn. You can scan the QR code, you can connect with me on LinkedIn, or you can, if you want to know more, you can send me.
It's nice. Any questions? Any questions, anyone? This company, what all provides? What all?
Which one?
Besides DevOps,
Mine?
consultancy, yeah, this
Yeah,
one.
DevOps, cloud, security, anything related to anything and everything related to infrastructure services, modern infrastructure services. So, yeah.
And I saw in the website certain training also, DevOps training.
Yeah, I mean, onboarding, teaching, yeah. Not, I don't do specific to, I don't believe in, you know, tool specific kind of training. I do based on use cases, because today for some use cases AWS is good, for example. Some use cases GCP is good. So based on the use cases, like I had shown in one of the slides, some of the incidents that I had faced, like onboarding these many users, or you know, how to meet this. So usually those things, those kind of trainings, those kind of onboarding.
Okay, thank you. Any more questions, anyone? Okay, thank you so much, Kamalika. Thank you.